we are gonna do another question, which is in p plus a by v square and v minus b equals to RT, which is van der Waals equation for real gases. Find the dimension of A and B. And sometimes in your exam the names of P, V might not be given, and in that case you would have to suppose what they generally mean. Since I know this is a van der Waals gas equation, I know P is pressure, V is volume, and R is universal gas constant, and T is temperature. So actually you must give what they are, but sometimes if they don't give you, you will have to guess on the basis. When they don't give the names of unknowns, it means that it is a very well known equation and you must know what each term means. So let's just write the dimension of everything. So here the dimension of P, which is pressure, it is force upon area, so it will be m L minus 1 T minus 2. Similarly, volume, the dimension of volume is L cubed. Now we don't need a dimension of R and T, but the dimension of R was very complex if you remember the previous video, and the dimension of T is just K, but we are not going to use this since we can do it just from here. So I'm only going to write two of these. So now if you remember principle of homogeneity, to add something, both of them must be the same quantity. So if the pressure is measured in pascals, this will also have to be a unit of pressure. Suppose it was Pascal, which means the dimension of P and A by V square will be same. Similarly, the dimension of V and B must be same, since subtraction and addition are basically equivalent. So it's not that the dimension of P is the same as the dimension of A, it is that the dimension of P is the same as the dimension of A by V square, the thing that it is being added to. So let's go on. So let's so from the principle of homogeneity, we have that the dimension of P must be equal to the dimension of A by V squared, right? So now let's put a pretty bracket around it. It's supposed to be a square bracket, but it's a round bracket. What can I do? So now what we are going to do is actually so the dimension of P is pretty simple. It is m minus 1 T minus 2. The dimension of A is the thing that we have to find. The dimension of V is L cubed raised square. So that means the dimension of A will be, so this will be L to the power 6. When going here, it will be m L to the power 5 T to the power minus 2. So this was the dimension of A. Similarly, the dimension of B can be found by using so let's use from principle of homogeneity. It's not a short form that is commonly used, but I'm using it to make it easier for myself. So now here the dimension of V must be equal to the dimension of B. So the dimension of B is L cubed, which will be the dimension of B. Therefore the dimension of B will just be L cubed. Hence the dimension of both A and B were found. So in the next video we are gonna do some more questions. So bye bye.